I'm a professor in physical oceanography, and in particular, we focus on how the atmosphere and the ocean interact between each other. And one of the phenomena where this interaction is the most active is in tropical cyclones or hurricanes. The first question we always ask is where the storm will be. So we were trying to extend the lead time. Of course, this is very important, especially for businesses. There's a lot of businesses along the coastline that are very susceptible to potentially, big impact, sometimes catastrophic impact of hurricane landfall. So there's a lot of preparations will need to be made. So businesses and the U.S. military. So there's a significant economic implication of improving the lead time of hurricane forecasting. And so the second question we ask is how strong the storm is going to be. And I should say that this is the most difficult problem in forecasting, to predicting the hurricane intensity. So what determines the intensity of the storm? The first is how much energy the storm gets from the ocean. One thing that controls the energy supply is the temperature of the water. And so if since the temperature changes, then amount of energy is changing. So in order to predict the hurricane intensity, we need to predict the temperature of the ocean underneath. In terms of the preparation and evacuation, this is enormously important to be able to predict well in advance which areas are going to be most likely hit by the storm. So there's one challenge in predicting the temperature, because we really need to know what's going on in the ocean below. So some years ago, we developed a computer model, and we created a so-called coupled atmosphere and ocean model. And so what this computer model does is simultaneously predict what's happening in the atmosphere and then what's happening in the ocean. Essentially, it's mathematical equations that describe the physics of the atmosphere and the ocean. With all the increase of computing power recently, we still don't have enough computing power to solve all the equations that we need to solve to predict the hurricane intensity. So try to develop a computer model or equations that describe all these physical processes. And this is what the challenging that we are facing. But we are making excellent progress. These are extremely challenging problems, but extremely exciting.